from there. So part one. So there's 3 parts to this. So part one is exploring geometric transformation. All right. So what I'm asking you, using your own words, define geometric transformation. So on the back of your notes that you got today, you're gonna write when you hear geometric transformation, what do you think? And then you're gonna share with your table mates. Okay. So I'm gonna give you, let's say, 90 seconds to write it down, and then you're gonna share with your able partner. Deal? All right, go. First off, great conversations, and thank y'all for actually doing it. But geometric transformations, when we think about that, I'm going to show you the next slide, and I'm going to zoom in, I guess, on what things you should think of. So when you're thinking about it, these are the words that we should think about when we talk about geometric transformations. No, you don't need to write them down. They're written on your notes on the other side. Okay. So you had dilation. You remember those? Yeah. So transformation geometrically is you're changing the shape, size, or orientation of the image, right? And that's called our pre-image. Our pre-image is the shape before we make that transformation. Does that bell ring? pre-image and image. Does that ring a bell? There we go. So we have dilations. We have horizontal translations where we're going left to right. We have a rotation around the origin where we're rotating 180 degrees. We have reflection over the x-axis. So when I reflect over the x-axis, that's my horizontal reflection, right? We have vertical translation. We're shifting the object up and down. We have reflection over the y-axis. That's my vertical reflection. We have reflection across the y equals x. Anyone remembers what the y equals x line is? It goes through the origin, but what? Anyone remembers? It's that diagonal line, right? It's that diagonal line that goes through your origin with the slope of 1, right? It's the parent function. It's just the diagonal parent function. Goes up and down, right? Left and right. And then rotation counterclockwise, 90 degrees about the origin. So when I'm rotating counterclockwise, there's two ways of rotating, right? We have clockwise, right? And we have counterclockwise, right? And each one of them affect our transformation differently, okay? So hopefully getting some gears going, yes? Yeah. What I want you to do is I'm going to show you 4 images, the 4 different transformations, and you're going to classify them as your table. So on the back of your paper or your notebook, wherever you wrote your quick write, you're going to classify the 4 things you see as either one of these 8. Okay. Yes. And then we're going to come back and talk about it. I'm going to give you 2 minutes. I'm going to zoom out so you can see all 4. I didn't put one. Whatever you want. Okay. All right. I'm trying to get it. Is that good? Yeah. Okay. So you're going to write down your lowercase a, b, c, d and classify them by the uppercase a, b, c, d, e, f, g, h. On the back of your notes or in your notebook, wherever you wrote your quick write.
Oh, wait. Yes, my bad.
Yes.
Killing all these sweats. I think you're having hard. All right, nah, why you guys? Ain't gonna see who's actually gonna buy me a brand new Xbox.
All right, 10 seconds left. Make final group decision on what A, B, C, D. Where do they lie?
It's still be the first one.
Okay. You don't know what? I forgot about these cards. Yeah. That is not y'all's period. It says second period, but it's not second period in there. What was I doing?
I don't think I'm gonna make it.
I don't know what I did.
Might like slow down my speech a lot.
That's first period. An 8th period box. Cool, cool, cool.
We'll start talking like they're going having my mom.
Let's see.
James has an M. If they raise the minimum wage, I could afford Dr. Pepper.
Not everyone did one.
They raised the minimum wage by $1.
David's in another class again. All right, here we go. Oh, it's not y'all. Huh? I know, I think that's what it is. I was like, wait, these are all jumbled. No, I gotta move them around. Because I forgot we had a whole bunch of shifts. Oh, here we go. This is our class. Got it. All right, this person, their favorite colors are pink and black, and they like Takis and monsters.
Oh, it's
You, Lily. Lily, what did you say was A?
I knew I was like,
We said reflection across the Y and the X.
yeah.
It is actually not. It is C. Monte, why did you say it was C? You made two 90-degree turns.
I heard doing the same voice you did.
So look here. Sound effects are our friends. All right, so it is C, is a reflection, it's a rotation around the 180 degrees about the origin. Now, I'm going to, again, I'm not going to assume that we learn anything in geometry anymore. I get it. But a rule to remember this is that your pre-image starts at XY, right? So notice that we started at 1, 2. In order for it to be a 180-degree rotation, there's one thing, I can't talk. There is two things that take place, and that's the sign of your X and your Y change. So notice that it was at +1, 2, and where did it land at? -1, -2, right? That's how I know that it is a 180-degree rotation. Okay. All right. Okay. Oh no, don't say that.
Yeah, you did. Yeah, it was
All
quick. We just didn't stay on it for a long time.
All right. This person favorite color is green, and they like sun chips. Green and like sun chips. Sounds. Oh, Jarvis. What'd you get for B?
Is what got D? Is that from?
We got D. It is.
Oh, you're supposed to put the letters.
So we got a reflection over the x-axis. So looking at this, what is the rule we can write here? So our pre-image is XY. What changed? But in terms of X and Y, it's a -Y. Our X's stayed the same, but our Y's became their opposite, right? Do we see that? That's why it's a reflection over the x-axis. That's what happens every single time. All right. Okay, let's see. This person, games, Lego, peanut M&Ms, favorite color is red. It is Anthony, Mr. Double Bass himself. Anthony, what did we say for C? It is a dilation. Think about your eyes. Your eyes dilate, right? Change in size is a dilation. All right. Next, this person wrote, favorite color is blue, Sprite. They wrote FIFA, Mexico. It was you. It was you.
You don't play football.
But you just felt like lying on your car?
Yeah.
Sick. All right, what did you say D was? D is a F? Yeah. Is that our No, it's not F. It's B. We just went left to right. Remember horizontal translation, right? It just slid. Remember a slide? Okay. So with horizontal translations, remember your pre-image is XY. Your image becomes whatever X is plus something, but your Y is going to stay the same. Okay. All right. So We're gonna keep diving in a little deeper into this. So on the other side of your notes, you should have all the points of this pre-image. So our pre-image is the blue triangle, ABC, right? On your note side, you have all of its original points. So 1, 2, 2, 6, and 7, 3. Okay. What we're gonna do is we're gonna talk about a coordinate function. We're gonna write the coordinate functions, and then you're gonna go through and write the pre-image and image based on what the coordinate function is. Does that make sense? Okay, coordinate functions. Functions are created to make our lives easier, right? To help us function better. Okay, and sometimes we do the same thing over and over. Functions were made, so we now have a rule to follow, correct? So we're gonna list out all the rules that we're following for each one, and then you're gonna go through and follow that rule. Make sense? All right, so starting off with, we have a rotation counterclockwise 90 degrees around the origin. What is our coordinate function? I can't talk. We're gonna rotate counterclockwise. That means we're going this way, right?
Yeah.
Around the origin, and we're gonna write out the coordinate function rule. So we have to transform any x and y. When we are rotating like this, that means that we are switching x and y place, but changing the sign of our y and keeping the sign of our x. So that's what's gonna happen every single time. Got it?
So it would be, so it's like,
We're gonna
I just wrote that in the wrong freaking place.
remember, we're writing the function, and then you're gonna go back and find the image. Got it? All right, next one, we have a rotation clockwise 90 degrees about the origin. So instead of going counter, we're now going clockwise. Yes, they're all the same points. You're still using the blue triangle that we used. Is that better? All right, so the rule that we follow every single time is the transformation to move your x and your y. With this rule, you're still switching your x and your y, but this time you're changing the sign of your x. So when you go counterclockwise, it changes the sign of the y. When you go clockwise, it's changing the sign of your x. All right, we're good? Okay, now we're gonna go on to the next one. I may be zoomed in too much now.
I think that you're a little,
I was trying to help y'all. All right, so translations. So this one, it tells us that we want to translate 3 units down and 2 units right. So if we're going down, is that adding or subtracting? Subtracting. It's a minus subtraction. And if we're going up to the right, that's going to be an add. So the transformation that takes place to our x and our y equals, what are we doing to our x? We're adding. And then what are we doing to our y? Subtracting. That's our rule we're going to follow. Make sense? All right, next, it says dilation centered at the origin with a scale factor of 2. Okay, when you learn about scale factor, you learn about your k value. So we know our k equals 2. If I'm changing the scale of something, I have to change the x and the y. So my transformation of x and y is going to equal what? X times 2 and y times 2, because I have to change both x and y. Dilation affects both. Okay, it'll be weird if your eyes dilated vertically and horizontally. Okay, it would be a little weird. All right, next one, reflection across the x-axis. What happens when you reflect across the x-axis?
You should jump over the line. Something changes.
What changes?
The y.
The y. Your y is going to change. Exactly, whatever it is, because you're just changing it, right? Okay, so reflection across the x-axis is that. What does reflection across the y-axis mean? The x changes. Oop. I haven't wrote it. I'm moving it. So for this one, yes.
Is this depending on like what the y is going to be like plus minus one?
Which one?
For reflection with the x.
It's what, so if your y is negative, a negative times a negative makes it a positive. So the math will change it itself. All right, and then last, we talked about this when we did our matching. What's gonna happen when we rotate 180 degrees counterclockwise about the origin?
Change in 180.
So the other one, we went which way? In our notes, we went. Do I need to go back to it? In the other image, we talked about it went just clockwise, right? So here we did, it's just a rotation of the origin, right? And what did we say the rule was? Both of them. Guess what? It's going to be the same because whether I go clockwise or counterclockwise, it's going to be the same. I'm going to end up changing X and Y. I didn't change one or the other. They both were changed. Does that make sense? Okay. So the transformation here is X comma Y is going to equal a change in the X and a change in the Y. All right. So your job for the remainder of the period is to write in the images and the pre-image and the image for each rule. Yes? Is that doable? Questions, comments, or concerns about what you're doing?
So we're using these numbers to get to.
Yes, you're using the same numbers every time. 1, 2. So just like the example one that was given to you, we use 1, 2, 2, 6, 7, 3, and then follow the rule for reflecting across the Y equals X, which means your X and your Y switch.
Can I graph this?
No graphing.
I really.
I will come.
I'm not doing it.
We will come and do the math.
It will be 1 negative 2. That first one, since it would be my brain not gonna work. I can't do it in my head.
So here you switch X and Y first, and then change the sign of your Y.
Yeah, so it still be 1 negative 2, right?
It would be
2 negative 1.
2 negative 2 1, like she's saying. You're changing your Y and switching your X and Y. Change your Y, switch your X and Y. All right. Okay, I will be around to assist. Don't be quitters.
I did something wrong. I'm already.
All right, so now that we've completed our rules, you can look up here and check yourself and see how you did. Following the coordinate functions and creating the images. And hopefully you feel good about it. Tomorrow we'll be doing part 2 and part 3. Thank you.